Most of what I'm going to be talking about here is actually going to be contributions that users in our community have added to Hammer. Very little of this is actually my work, so I really appreciate all of our open source contributors, many of whom are here. Please keep up the great work. So, what has Hammer been up to in the last year, and why is my machine not responding? Okay, so we promised you 5 backends, and now we actually have all 5 of them. So Packrat is still handling all of our context-sensitive grammars. GLR works for that as well. We have LALR and LLK on the context-free side, and a regex VM for regular languages. Cool, so that's all in the can finally. We also finished a ton of language bindings, which I didn't actually list on this slide because you can just find them on the website. We added a lot of new combinators because it turns out that protocols are assholes, and they will come and they will come up with ridiculous design decisions that make us add new things. Like what, you say? Endianness. There exist protocols that switch endianness on the fly. TIFF is one of them. You have to there is a byte that you read in the magic header, and it tells you whether the rest of the file is little endian or big endian. So now you can switch that up on the fly. H-aligned. Sometimes protocols care about whether bytes are aligned. I mean, this I'm pretty much okay with. This is kind of a special case of an attribute constraint, just making sure that things line up correctly. I cannot say the same for these guys. These are DNP3's fault. DNP3 is so aggressively context sensitive that we basically had to introduce a symbol table with scope in order to be able to handle all of the bullshit nesting that's in it. H permutation is PNG's fault. If you read the PNG spec, you will think, oh, this is a really cool spec. This is a really nice design. Eric Raymond was totally right. And then you get to the part where there are like 5 different there are like 5 different required things that can show up in any order. So fortunately, Parsec, the Haskell parser combinator library, introduced a permutation combinator a while back, and Pesco, who wrote most of these other guys too, implemented that for us. He also implemented monadic bind. So this one also ended up being DNP3's fault, and it's a nice way to sequence parsers together, much like you do in Haskell. So this one came in from out of nowhere. I have an algebraic topologist buddy, Michael Vedema Johansson, and he got really interested in generating functions recently, and so you will now find in the examples directory code for producing algebraic generating functions from a context-free grammar. A generating function is basically a power series that lets you enumerate the size of, well, in this case, a grammar. Okay, we've also been working on some protocol implementations. In my copious free time, I've banged out PCAP, and from there, I've been working on Ethernet, IP, TCP. I don't actually have anything on GitHub for that yet, but I'll get there. Pesco and Adam have been working on DNP3. It's about the biggest, nastiest protocol we've run into so far. It's substantially worse than MP4. The long-range data dependencies, like I said, required us to add a freaking symbol table to make it work. But this is definitely testing the usability of the library in terms of what convenience functions does it provide you to make it easier to conceive of this horrible, enormous thing. So I mentioned Michael's generating functions. I didn't tell you what they were for, and they are for the grammar of tie knots. In 1999, a couple of physicists, Fink and Mao, enumerated all possible tie knots, like necktie knots, starting from the wide end of the tie, and they came up with 85 of them. And then Michael was watching The Matrix Reloaded and noticed that the Merovingian's tie is not in that list. It turns out that you start that tie from the small end, and so we investigated this. You might have seen, like last year, there was like a piece in New Scientist that said 177,000 possible tie knots. That was us. We actually got that wrong. It's actually more like 266,000, and that paper's coming out next Wednesday. We've also put together a series of tutorial videos on Hammer with help from Stefan back there. It's basically a code along. The early videos give you just some basic introduction to how the library works, setting up the development environment. And then we jump straight into base 64 and then move on into JSON RPC. And that ends up requiring sequencing a bunch of parsers together to give you an idea of how to build more complicated systems by composing parsers. So the beta version of that is up on GitHub. There are notes, there is source code, there are videos. Please let us know if you run into any problems. So what's coming up next? I'm planning on adding one more backend, All-Star, which is what Antler uses these days. It's Terence Parr's algorithm. We've had some confusion from users about Packrat as the default backend because it turns out that ordered choice, which is to say a choice operator that forces you to put prefixes after things they're prefixes of. So for instance, like if it's a choice between foo and foo bar, you have to put foo bar first in your list of choices. Otherwise it will never match foo. So this turns out to confuse users, and so we want to retire that as fast as we can. I'll be adding some more bindings. I've been working on Lua. Other contributors have been working on Rust, and of all things Haskell. I can't figure out why, but it's really nice. Profiling and optimization, as Jeffrey pointed out, are clearly desperately needed. And there are a lot of naive optimizations, fortunately, that we can do to make stuff a lot easier. Like with the MP4 files that that you were opening, you're reading like these giant buffers that have like a size of tens of thousands of bytes, if not more. And when you're applying the int8 parser over and over and over again, it turns out that doing that naively requires a lot of allocation and takes forever. So there are definitely some simple optimizations that we can do to make that less stupid and hopefully faster. I mentioned that I've been working on some protocol grammars. The thing that I'm basically blocking on before I release that is a nice general test framework, so that if you decide to write a protocol grammar, you don't have to go through a bunch of hassle to test it and make sure it works. And finally, Michael and I are going to be using the generating functions stuff that we've been working with to see what we can explore in terms of attack surfaces. I mean, you start to get into kind of aesthetics here almost when you're talking about when you're talking about what the when you're talking about subsets, interesting subsets of a topological space, which is essentially what these generating functions are sketching out here, like a set of some strings in the set of all possible strings. And so within that, there's also going to be sets of interesting strings, which is to say, like strings that provoke interesting backend behavior. And so we're going to try to see if we can characterize these a little better and a little more mathematically. And then I mentioned the paper on this is coming out in PureJ Computer Science next Wednesday, so that'll be online. Please enjoy. And that's all I got. Any questions?
Questions? Well, in that case,